Welcome back, everyone. We're moving into the afternoon session. I hope everyone had a wonderful lunch, you're hydrated, and you're ready for these amazing presentations about to come at us. We're starting off our afternoon session with Mike Lynch. Mike Lynch works in the e-research support group at the University of Technology, Sydney, and probably writes more code than his job description allows for. His recent work has focused on the use of open source software and open standards to describe, publish, and preserve research data. Arkisto is a project for digital data preservation, which focuses on sustainability and reusability based on open standards, taking a data-centric approach. Mark is going to walk us through the key standards and concepts behind Arkisto and show a couple of applications of its use as a data publication repository at UTS and at Paradisic, an extensive collection of cultural data around endangered languages. Mike, over to you.
Thanks, Bonnie. Hi, everyone. I'm Mike Lynch. I'm in the e-research support group at UTS. So e-research is a term for the sorts of specialised IT support for academic research. My team covers everything from really techie stuff like running high-performance computing clusters out to policy and ethics guidance to researchers on how to protect personal information in health data, that sort of thing. Today I'm talking about Arkisto, which is a platform we're developing in collaboration with some other institutions to try and make research data description, management and preservation more sustainable. I'll talk about the standards and tools we're using for this and then follow with a couple of case studies. Sustainable research data preservation. Researchers produce a lot of data. What a lot means varies between disciplines. Traditionally, this gets seen as a STEM problem, but humanities disciplines have big, unwieldy data sets as well. Researchers don't want to describe their data. They want to use it and get publications out of it. Us research people and the librarians who we work with, we love to help them describe their data, but there aren't enough of us to go around. And so that leads to a situation where you have petabytes of storage with file shares on it belonging to researchers, full of data without much metadata about who it was made by, which grants funded it, or detailed discipline-specific information. And this is a problem for sustainability because it means it's hard to make decisions like, do we need to keep this? How long do we need to keep it? Are we allowed to move it to slower, cheaper storage and that sort of thing? One of the ways institutions have tried to deal with this problem in the past is with repository software. This can either be discipline specific. For instance, we use Omero, which is a repository for storing microscopy data, or general purpose, like Fedora, which is not the Linux Fedora, but Fedora Commons, a fairly well-established repository, general purpose repository, or Hydra, which is based on a Ruby on Rails stack. They can help with these problems by doing things like capturing metadata from the equipment that generates the data, or have UIs that prompt the researchers to describe it. And they have APIs for getting data in and out. But they come with some problems. Because they're software, even though they're often free or open source, they're not free to maintain. And the specialized ones in particular have often been built by academics who are really good at their particular discipline, but they're not especially good at general purpose software engineering, so that they have kind of problems. People argue about what big data means exactly, but I've decided that big data is anything that can make your sysadmin swear at you. And I've found that specialized repositories often have that problem. And they'll always hit a scale issue at some stage where someone is going to try and put something through the API which just won't fit. At that point, you start to do things like sideloading. You put the big stuff on a file system with some kind of link between it and the record in the repository. And now that's another thing you have to maintain and keep in sync. And also migrating data, even from one version to another of the same repository, always causes hassles. Arkisto builds on a couple of standards, emerging standards, which have taken the lessons of the last decade of repository software development to heart. We already have a stable, performant way of storing data, which has decades of history behind it and a promising future, and it's files. A few years ago, we've got some colleagues at UTS who work in big data set visualization, and they've got this lovely round room with 7 projectors that can do incredible visualizations of huge data points sets. And they've also got experience in Hollywood doing CGI for feature films. And we were a bit starry-eyed and saying, we'll try and build you some kind of system for managing your data. What's your preferred API for accessing it? And they just said, give us an NFS mount, please. And we sort of laughed at that, but we've eventually come around to thinking, yeah, actually being able to mount a disk with it, if at some point we're going to have to sideload large items, then we can store everything on disk. It seems with this that we're back where we started, with our research data store being just a bunch of stuff. Arkisto is meant to stop it being a bunch of stuff. The other thing that we're addressing, or the other problem that we're addressing, is legacy collections. These are different from big institutional research data stores with all sorts of stuff in them. They're single purpose. A researcher or a team of researchers has put time, love, and dedication into curating a data set. They've found a postgrad with some tech skills, and they've made a nice website with either a custom LAMP stack, or they've used Omeka or Mukurtu, one of the packages that deal with this, and they've got their research online. Then the grant ends. One or two of the researchers leave. The person who built the site gets a postdoc and goes off somewhere. Eventually, a sysadmin somewhere is doing an audit of what things need their operating system patched, and they go, what the hell is this? Is anyone going to yell if I turn this off? The scenario I've described happens in science as well as in the humanities. The scientists are often using databases for performance reasons because their stuff just won't work if it's files on a web server. So we're always going to have to deal with this sort of bespoke research-driven collection. But with Arkisto, we want to provide more sustainable ways to build them, but especially a sort of sustainable way to preserve them once, so we don't have this problem of them just petering out and being someone else's problem. We can package up the data in a format that preserves it and allows it, hopefully, to be reconstituted. So the name Arkisto is something that we picked. This stuff we've been working on this stuff before the term existed. It's Finnish for archive. Last year, we needed a name to apply for an ARDC, that's the Australian Research Data Commons grant, last year, and we couldn't find anyone else who was using the term Arkisto in this space. We didn't get the grant, but it's still useful to have the term for it. Arkisto is a platform for sustainable research data preservation. It's not a single piece of software, but it's an approach to building tools and systems which is based on some standards for storage-centered repositories with metadata and a sort of general development philosophy. Before I get into the standards, I'll talk about that philosophy. The first one is that data and metadata on disk or in an object store is the source of truth. And where possible, it's immutable. You want these things to be reference data sets, so you can add to them, you can put another version, but you always want previous versions to be around. Arkisto repositories can have secondary data products which make things discoverable and more efficient, like an index to be able to search, that sort of thing. But these secondary data products should be seen as sort of ephemeral and easy to reconstitute from the primary thing, which is the data. So in IT language, it's like a DevOps approach to secondary data products, rather than having them be these things that you have to fuss over and tune and then try not to break them. We have some configuration that says how they're derived from the original data and automated processes to spin them up. And because we're taking this DevOps approach, we can use the sort of DevOps tools that we use for the rest of our IT jobs. We don't want to build monoliths that try and do everything. We want to build components which do one thing well, or at least not badly. And linked to that, we use a sort of incremental development philosophy, whereas rather than saying we're going to spend the next six months overhauling our repository, we're going to spend a couple of weeks improving something to make either our lives or our users' lives easier. A lot of our tooling is kind of in early stages, and none of the stuff we've got now is necessarily going to scale well. But again, we're not trying to solve all of these problems at once. And we don't have a preferred language or software stack. Pretty much all of the stuff I'm going to show you today was developed in JavaScript using Node, because that's what we're doing at the moment. But one of the points of Arkisto is that these things have lifespans that are longer than software trends. So by relying on standards, it means that in 10 years, when there's another new shiny, that can be used to deal with the fundamental thing, which is the data. So getting into standards, I'd first like to note that this presentation is XKCD 927 compliant. I was worried a bit that people wouldn't get that joke, but I think it's obvious for this crowd. The two standards we're using are RO-crate, research object crates, which are a way to describe each of the collections in a repository. So that's on the data set level. And OCFL, the Oxford Common File Layout, describes how to lay out a set of these collections on disk in a kind of transparent and maintainable way. What constitutes a collection really depends on the application. It can be a single data publication, or it could be a data set with terabytes of data that represents years of research. So I'm going to take you through these standards and actually show you what they look like sort of from the inside out. An RO crate looks like this if you browse it. This is a publication which my colleague and former boss Peter Sefton crosswalked out of an Omeka repository. It represented a fairly big history project called Farms to Freeways. And so this is data that was in one of those bespoke collections and has been written out to files. So here's a human readable thing that you can, if you were given this data set in a zip file and you opened it up, you could see this, and it has metadata. It's got the name, it's got a description, it's got who created it, when it was published, that sort of thing. There's also a link to the same metadata in a machine readable format in JSON-LD, which I'll get to. So RO crates are the descendants of two earlier standards. One of them was research objects, which was another effort to make self-describing research datasets, and data crates, who Peter Sefton came up with originally, and brought to it this idea of using linked data in JSON to describe things. So this is a look at, and I'm not expecting people to read through this, but this is what the JSON-LD looks like. The HTML we saw on the previous slide is generated from this JSON-LD, and the JSON-LD contains all of the information, all of the metadata for the RO crate. The definition of an RO crate is a directory with this kind of metadata file in it. It can have the landing page, and it can also have some payload files. There's no rules about how the data inside those files is structured or how the directories work. And it's perfectly legitimate for an RO crate to have just the metadata files. Sometimes this is useful because there are lots of times where you need to publish a data set, but not also publish the payload. It might be protected by ethics or a confidentiality agreement. A lot of times researchers want to be asked before they grant people access to the data, and this is the sort of thing that comes up in archives as well. There's no requirement that every file in the payload has an entry in the JSON-LD file. The detail can be as much as is appropriate to the application. And one of the important features of RO crates is that if you're given a directory of stuff or a file share that a researcher is using on your research store, you can turn it into an RO crate simply by putting one of these metadata files in it. The metadata format JSON-LD is a general purpose way of doing linked data in JSON. So it defines two things. It has a graph, which is the list of items, things like the data set, a person, a file, and then properties that relate those items. So the person is related to the data set by the property author, files are related by the property has part, that sort of thing. The RO crate community decided with the graph comes a context. The context is the definition of what the links between the objects are. And the RO crate community decided to use schema.org as its vocabulary. It has had a bit of a bad reputation sometimes in scholarly circles because it's very much the creation of big tech. It has lots of ways to describe selling things to people, and it doesn't have a lot of detail around scholarly publication. But it's quite well supported. Things like Google's data publication search use it, so RO crates already automatically work with that. And I won't dive into too much detail. On the RO crate website, we've got a lot of use cases about how to use JSON-LD to model the typical sorts of metadata that are useful for this sort of research data. So We can model things like data provenance. If you had a raw data file and then a downstream data set and some software that was used to analyze it, you can capture that relationship. You can also do data licensing, so express rules about who is allowed to look at this data set. So that's Arkisto, that's RO-Crate. An Arkisto repository is one or more of these RO-Crates stored as OCFL. There's no really fun representation of an OCFL, so here's a cartoon which shows you these data lumps sort of marshaled into yards with a little description in front of them. OCFL is an acronym for Oxford Common File Layout. It can be stored on an object store like S3. The file thing is a bit of an artifact of its history. Like RO-Crates, OCFL repositories are a file system with some contents and some JSON metadata files that tell us about the contents. And the specification tells us how to do two basic things. One is how to lay out the objects which correspond to RO-Crates on disk. The most common option is a sort of a pair tree algorithm where you take an identifier and chop it into 2-character chunks and then use those as a path. The other side of the spec is telling us how to keep version collections inside the OCFL objects. So I could sort of numb you with details about this, but I'll try not to. The most important thing about OCFL, and one of its most useful things, is its versioning. So an OCFL object is described by an inventory.json file, and that the best way to explain that inventory is that it has two lists. One is a list of the hash of everything that's ever been added to this object, with a path to where it is on the disk. And the second list is a list of object versions. Each version has a timestamp saying when it was created, and then a list of the hashes of the file that are in that version. And this means that the entire history of an object is always available and can be reconstructed. The picture on the hand holding the hard disk is one of the OCFL logos. This is meant to be sort of like, even if everything is collapsed around you, if you've still got the hard drive and you've got the files on the disk, you can reconstruct these revisions. It's not at all designed to be efficient. These things aren't like Git where it's super fast. It's rather designed to be transparent and identifiable from someone who doesn't have specialized software. It sort of shows its origins in the archiving and preservationist world here. So the idea is this, that if you've stored something in this format, then 10 years from now, someone who has a copy of the spec and basic coding skills can start to get stuff out of it. That brings me to a bit of an interlude about who exactly is all this for. I said at the start that researchers don't want to describe their data. They're an audience for RO-Crates in as much as they want their landing pages to look nice when they publish data to accompany a journal article. You know, something like this with sort of a nice heading, some thumbnail images that show some visualizations. But we're not going to expect them to learn JSON-LD to build this. And likewise, they might like the idea of having a website with versions, but they're not going to learn about OCFL. So it means that generating RO-Crates and moving things in and out of OCFL needs to be automated and seamless, and not something the end users have to worry about. We've been building up production systems for doing this incrementally. So we had a release of our data publications using RO-Crates. Then we swapped those were just stored on a web server. Another release, we put an OCFL repository under that. And then last year, we added a search and discovery portal over the top. I said before that an RO-Crate is a directory with a metadata file in it. The hard part is generating that metadata file. The three main ways we're doing this: we have a command line tool called XLRO, which traverses the file system and builds you a basic RO-Crate that you can then add metadata to. The tool we're looking at here is called Describo. This is an Electron app which was developed by Marco La Rosa from Paradisec, and it allows you to, it'll look at a directory on your hard drive, traverse it, find all the files, and then present you with an interface where you can start saying, okay, what's its name, what's its description, what license is it published under, that sort of thing. It's a bit power usury at the moment. It kind of presumes that you know what what an RO crate is, and it needs a few iterations of user testing before it becomes something that we can just roll out in front of researchers. The other thing that is very experimental with Describo is we've got a prototype which, instead of looking at local storage, will connect to a OneDrive share, and we're hoping to let it use rclone, which is a really useful tool that will connect to all sorts of cloud storage. Sort of to have this idea of when we want to publish some data, we don't ask the researchers to give it to us. Instead, we say, here's a tool that you can point at the storage wherever you've got it and generate the metadata for it. The third way we're creating things, and probably the way we're doing most of them, is by crosswalking metadata from existing systems. So our research data management and publishing system, which is called Stash, has a web interface where researchers can describe data publications and upload them up to a certain point, and then it just takes that and uses a JavaScript library to generate an RO crate. Our toolkit for OCFL isn't really as mature as our RO crate stuff. Where the publication system I just described uses our Node OCFL library to add things to the OCFL repository. We've got a couple of command line tools which use the same library to enable us to deposit things manually which are too big to go through the web form. That needs a lot of work. The current tool is really minimal and old school. It doesn't give you anything like a progress indicator. It just sits there till it's finished, and if it doesn't say anything, that means it worked. So then I've talked about OCFL and RO crates, but by itself, an OCFL repository full of RO crates isn't particularly useful if you want to find the stuff in it. And that's where we come to ONI. ONI is our user-facing web stack, which allows faceted search and discovery within an Arkisto repository. The name was originally an acronym for OCFL, Nginx, and an index. And Oni is a kind of ogre from Japanese mythology, and I'd seen two really good sculptures of a red Oni and a blue Oni at the Art Gallery of New South Wales when I was trying to come up with a name for this thing. They're kind of scary, but in some stories at least, they're not as scary as their reputation. The first version used Nginx, but for fiddly technical reasons, we weren't allowed. Nginx couldn't do some of the authentication that we wanted. So instead of using Nginx as the web server, we swapped it over to express.js, which is a fairly simple Node JavaScript application server. So now the N stands for Node. This is an example of sort of our development philosophy, in that if you've got good standards to code against, it's not too painful to swap out part of your tech stack. And refactoring it from Nginx to Express was a couple of weeks' work. So what ONI does is it scans an OCFL repository with well-described data sets in them and turns that RO crate metadata into an index. We're using Apache Solr for that. And then it provides a discovery interface to that index. So here's what our research data portal looks like. I'm sure that the actual text in those items is too small for you to see, but what we've got is the front page of the UTS Research Data Publications portal. It's a basic faceted search, so everything, you've got search results on the right side, and then on the left we've got lists of facets like author, keywords, date published. Everything we're seeing here comes from the Solr index. This stuff isn't coming directly from the OCFL repository. And the search results here correspond to the top level data set in each RO crate. The facets are generated according to how the index is configured. So for instance, in the config for indexing a data set, we say, okay, the author property should be a multi-valued properties. A data set can have more than one author, and you should facet on that. Then the actual faceted search is taken care of by Solr. Again, we didn't want to write a search engine. Solr is a perfectly good open source search engine, so we're happy to let it do that job. There's a bit more configuration controlling which facets appear where in the display, but the idea is that you don't have to write very much code to use this in a different application. The Components of ONI is the underlying OCFL repository, the index, and the single-page web app I just showed you that returns the search results. When somebody clicks through one of the search results, they'll get taken to the HTML landing page of the RO crate, and that just gets passed straight through the Express web app. We've got some code which is still a bit raw and experimental, where we are using licenses on the data sets to authorize their visibility in the search interface. So an RO crate will have a license that indicates, okay, this data set can be viewed by this group of people. Then when someone goes to ONI, they authenticate against it, and the system can find out what groups they're in, and then filter the search results and the actual payloads based on that. This is a requirement for using ONI to search an internal institutional repository, because the internal stuff isn't ready for publication necessarily, and we need to have control over who can see what. So the most important idea here, going back to those Arkisto points, is that the primary source of truth is the OCFL repo, and that the index itself is kind of ephemeral. It's generated from the RO crates by a declarative config file. A common problem with bespoke data management for research collections is that you need to make decisions about granularity. So we've got a collection with many data sets, and each of those data sets might have hundreds of files. Should the search results return data sets, or should they return files? This sort of decision can get baked into the collection and the tools that work with it, and changing it later on can require effort. It also doesn't make it easy to provide for changes in the model arising from the research itself. Research data is exploratory by nature, and when we're applying only to data sets for a single project, we want to encourage the researchers to feel free to go where the research takes them, not where our design says that they should. We also need only to be able to index things at different scales. For an institutional repository, that will be a single data set, but only can work on a large data set and index the things inside it, like a person or a place. That brings me to the first of the case studies I'm going to show you. And this is an example of this is a collection from one of our historians, Dr. Alana Piper, which is called Criminal Characters. Her research methodology is to take court records from the 19th century, and then she crowdsources this with Zooniverse. People transcribe these and then turn them into linked data structures. So instead of just a list of text court records, you've got people who are linked to a set of convictions, and each of those convictions has a date and a location of the court where they were convicted. This screenshot comes from some work that my colleague Peter Sefton has been doing on rendering the results for one person, so all of her convictions, into a map viewer. And it shows how we're building parts of this toolkit that can do more than just pull text out of a metadata file and into an index and present it for the viewer. We want it to be able to deal with structured data like GeoJSON and other applications that come down the pipeline for particular researcher needs. And building up this toolkit means that we can reuse these components for other data sets. So our Paradisec, which is an archive of linguistic data for endangered cultures, has about 90 terabytes of linguistic data. And in 2020, Marco La Rosa and Nick Thieberger got a grant from the ARDC to modernize their catalog. The catalog's about 18 years old now, and it's kind of in need of renewal. So working with them, we helped them to use the core Arkisto standards, that's OCFL and RO crate, to crosswalk everything from the catalog into OCFL with RO crates describing it, and then make it accessible with a discovery interface. This is a different web stack to ONI. Marco's used Elasticsearch rather than Solr, and the custom front end is something he developed in Vue. And again, this is very much in keeping with our ideas that we're not trying to restrict what tools people use or what software packages or languages they use to make this stuff discoverable. It should be whatever's appropriate to the team working on it. But because it's on OCFL and RO crate, it's not locked into the tools that have been used to make it discoverable. And future developments. This year, we're looking at applying these Arkisto principles to the other end of the research data pipeline. Most of what I've shown you today has been about research that's already been done, and we're figuring out good ways to index it and present it. We've got some researchers in the life sciences with remote sensors in estuaries, and we're looking at what they want to do is a way to organize this data as soon as it comes in. We would like to use a dedicated OCFL repository to take the CSV files that come from the sensors and put it in as early as possible and put it into an immutable data source. So we've got a sort of live archive that's growing all the time. Then we can put an ONI over the top of this to provide access to the data faceted by where it came from, what time it came, and what data they want to look at. For this, we're also looking at extending ONI so it can do a bit more with the contents. It can actually dive into a CSV file and surface columns rather than files, and become a sort of data API server. That's really hand-wavy, and I've no idea if we'll actually get to it. Another way we want to extend ONI in its role as a data publication server is to look at more useful ways of letting other researchers fetch data to reuse it. We've been packaging things up in zip files, but they're impractical for a bunch of reasons. You can end up with twice your storage requirements. You don't want to generate them on the fly necessarily. Generating them can be really time consuming. So we would like a feature in ONI where people can browse through a data set and then get a link off it that they can then take away and use something like curl or wget on their command line to go, okay, right, fetch me this data, and it'll just pull them down to where they want to work with it. It would be great also if we could use that for coding environments like Jupyter notebooks, where you've got researchers using Python to do stuff in browser. It'd be really nice to give them a URL that you could just pull something and turn it into a pandas or NumPy object that you could immediately start reusing. And the other thing we'd love in the next year is to find more people who are interested in collaborating with us on building these systems, giving us feedback, and helping us develop it further. So I'm assuming that I'll be able to publish this stuff, and you'll be able to. All of these things that I've described have websites with more or less detail about them. We've got a whole bunch of code on GitHub. You can actually look at the modern paradisic thing that I showed you. And yeah, there's my emails there, and I'm also at Mike Lynch at oz.social on Mastodon, and you can hit me up in the chat. So thanks, everyone.
Hi, Mike. Thanks for that. I think, look, what struck me as I was listening to your presentation is the scope. I mean, obviously you're working at a academic institution here, but the scope, particularly for like our cultural heritage institutions, to sort of think about how they're packaging up their own data sets for use by, for example, academic researchers or whatever it is, and how this might be integrated into some of the ways that they provide that.
We worked, I think it was a bit over a year ago, we did some work with the State Library of New South Wales at crosswalking some stuff out of, I think it was METS was the format it was in, into these formats again for that sort of sustainability, those sustainability things that I talked about. So
and I think that building in of sustainability thinking is really important when we consider a project. So often there's the focus is on that delivery, and we look at use and measure that for X amount of time, and then projects just can kind of disappear. And I think building sustainable thinking into projects holistically is really important, and having tools available like the one you presented today is really important. The other thing that really struck me, and it was nice to see Alana's criminal characters project there. I've had a conversation with Alana around, again, cultural heritage institutions, sort of, we digitize things, but we don't datafy them. I think that's the word that we actually made up, but that datafication of the stuff is more important than just, I mean, obviously you need to digitize first, but it's
Yeah.
sort of a lost aspect, and as in that project, Alana's crowdsourcing it, but I guess there's for institutions to kind of think about that. Do you agree?
Yeah, definitely. Like her work, and there's a couple of other people we're working with, like Tams and Peach, who are doing this really exciting stuff where they're taking humanities data and turning it, like I said, into linked structures that you can then explore with the same kind of tools that you would use for STEM stuff. And yeah, it's really promising, and we'd like to see and support more of that. So
it's so exciting. Like, it's just such an exciting time to sort of be in cultural heritage and to have these bridges. Now, I'm absolutely hogging you with questions. So what we might do is wrap up here, and I'll let you jump into our chat over with everyone who's eagerly waiting for you.
Okay.
Beautiful. All right. So we will reconvene in about 10 minutes. I'm excited with where we're heading. We're going to be hearing from Molly Tebo and Tricia McKenzie around their COVID lockdown project. So can't wait for that. We'll see you in the chat back in 10 minutes. Thanks, guys.
Thanks. Yeah.